Physics, light or optics. Today we are looking at the part 2 of the light or optics. We look at the following outline. First, we look at the ray box. Next, rectilinear propagation of light. And then we'll look at shadows and eclipse. And then we'll look at the pinhole camera before we look at magnification. And then finally, calculation. The ray box. Rays of light are produced in the laboratory by the help or by means of a ray box. So we use the ray box to produce rays of light in the laboratory. A ray box consists of an electric lamp and a very narrow slit arranged to produce very narrow beam of light. All right, you can see the box. There is a slot, a lamp that we can put fixing bulb. Now you can also see the diagram clearly here. There's a light bulb inside. It produces a narrow beam of light, the yellow light you are seeing at the front of the bulb. All right, there's what we call a slit where the light passes through. Now the rays from the light in the box comes out from a slit in front of the box. Now, the slit is just a small opening at the front of the box. Okay. Rectilinear propagation of light. The phenomenon of light traveling in a straight line is what we call rectilinear propagation of light. Now, this phenomenon brings about two important parameters, two natural effects that result from rectilinear propagation of light are the formation of shadows and what we call eclipse. Let's look at them. Shadows. A shadow is an area which light cannot reach because of the obstruction of an opaque object. All right, if you look at the diagram, there is a light source, then the sphere there is an opaque object which hinders the light from getting to the screen. So you see a shadow cast on the screen. Okay, shadows are produced by opaque objects. An opaque object is one which does not let light pass through it. Eclipse. This occurs when the position of the sun, the moon, and the earth are varied in a straight line. Okay? We have eclipse of the moon and eclipse of the sun. Let's look at them. First, we start with eclipse of the moon. This occurs when the earth comes in between the sun and the moon. The moon is in the earth's shadow cast by the sun. Let's look at a simple diagram for it. You see the sun, you see the moon, the earth is in between. All right. At the back of the earth, there is what we call umbra, where no light reaches at all, and then penumbra, where little light will reach. Okay. Next, eclipse of the sun. This occurs when the moon comes between the sun and the earth. This makes the shadow of the moon to fall on the earth. Let's look at the diagram. See the diagram, the sun, the earth, the moon is in between them. You also have the umbra and the penumbra. Okay. Next, the pinhole camera. This consists of a light tight box. One end of it has a small hole made with a pinhole or needle point, while the opposite end has a screen. It's not like the ray box where there is a lamp, okay? The screen is made with tracing paper. Now, if a brightly light object is placed a short distance from the camera, it will form an inverted image on the screen. Okay, so as long as the object is bright, it will be seen on the screen. Images are formed on the screen when objects are placed in front of the camera. The simple camera is shown. You see that the object is standing in front of the box, and on the screen inside the box it is inverted. So images are inverted in the pinhole camera. Magnification, M, we use M to represent it. It can be defined as the ratio of the image height to the object height. Okay, or we can also define it as the ratio of the image distance, okay, to the object distance. Now, image distance is also known as the length of the camera. Take note. Now, note the following. If M is greater than 1, that means the image is magnified, as in the image is more than the object. If M is between 0 and 1, the image is smaller than the object. Mathematically, M equals V over U, where V is the image distance and U is the object distance, or M equals HI, height of the image, over H naught, height of the object. Any of the formula you can use. All right. Now I'm going to give you one exercise. Please, I want you to solve it and get the answer to me. Exercise. The length of the camera of a pinhole camera is 15 cm and the object distance is 7.5 cm. Calculate the magnification. Don't forget the length of the camera is the same thing as the image distance. All right. So I want to get your answer. Thanks for being in the class.